Hello and welcome to helpyourmath.com. In this video, we're going to look at verifying trigonometric identities. And before we get started on that, let's review the three Pythagorean identities. The first one of which we should all know and love, sine squared theta plus cosine squared theta is equal to 1. The other two we can derive directly from sine squared theta plus cosine squared theta equals 1. So that way you only have to memorize this one, and then you can always figure out the other two based on this. Because my theory is the less you have to memorize, the better off we all are. How do we come up with the other two? Well, take this sine squared theta plus cosine squared theta equals 1 and divide everything by sine squared theta. So if I divide everything by sine squared theta, and sine squared theta, what's that going to give me? Well, sine squared theta divided by itself is 1. Cosine squared theta divided by sine squared theta, that is cotangent squared theta. And 1 over sine squared theta, that's the reciprocal function, that is cosecant squared theta. So there's a second Pythagorean identity. And the third one is when we take that starting identity and divide everything by cosine squared theta. So we're going to divide everything by cosine squared theta. And that's going to give me, let's see, sine over cosine, that's tangent squared theta, plus 1 is equal to secant squared theta. Right, so we can always get those original three just from knowing the 1. Okay, what we want to do is we want to verify that sine of alpha times cosecant of alpha minus sine of alpha is equal to cosine squared alpha. Remember, when we're verifying identities, when we have two sides, we ignore one side. So we're going to start over here on the left side, and we're going to totally ignore the right side. What does it look like we might want to do here? There's a few options, one of which is maybe we distribute the sine of alpha. So if I distribute sine of alpha, I would have sine of alpha times cosecant of alpha minus sine alpha times sine alpha will be sine squared alpha. Okay, now what? Well, cosecant alpha, that's the reciprocal of sine, so this is sine of alpha times 1 over sine of alpha minus sine squared alpha. And then if I put sine of alpha over 1, look what happens here. Those cancel each other out, right? Because any number times its reciprocal is equal to 1. So then I have 1 minus sine squared alpha. And what is 1 minus sine squared alpha? Think back to that trig identity that says sine squared, I'll use alpha here, plus cosine squared alpha is equal to 1. Does this kind of look like that? Yeah, if we subtract sine squared alpha from both sides, then what we have is that cosine squared alpha is equal to 1 minus sine squared alpha, which is exactly what we have. So this is equivalent to cosine squared alpha, which is what we were trying to show. Okay, why don't you try this example? Were you able to do it? Let's see. So we want to show that tangent of beta times cotangent of beta plus tangent of beta equals secant squared beta. So first thing I want to distribute here. I'll get tangent of beta times cotangent of beta plus tangent of beta times tangent of beta would be tangent squared beta. Okay, now it's up to you how you want to deal with these. We can rewrite them in terms of sines and cosines if we want to. So tangent would be sine of beta over cosine beta, while cotangent would be cosine beta over sine beta. You could also just say, wait, cotangent, that's 1 over sine, or 1 over tangent. You could probably also do that, but either way. And then here we get tangent squared beta. Not much we can do there. Okay, what happens here? The sines cancel, the cosines cancel. And again, this works because these are reciprocals of each other. So now we have 1 plus tangent squared beta. Can we do anything with that? Think back to that trig identity. There is a trig identity that said tangent squared, what are we using here? Beta plus 1 is equal to secant squared beta. So it looks like we can apply the trig identity right now because this and this are the same thing. It's just the commutative property comes into play. So we can rewrite 1 plus tangent squared beta as secant squared beta, and thus we have shown that those two things are equal to each other. These have been examples of verifying identities using identities. Thank you for stopping by.